Exercise 10D, question number 1. The resultant forces F equal I plus 4J act on 2 kg. When you put F equal MA, this is going to be I plus 4J times M is 2 and A. So A equal half times I plus 4J. So this is going to be half I plus 2j or 0.5 I plus 2j, and find the magnitude and the bearing. So this is I and this is 4j. So those are the forces actually, 1 Newton and Newton 4, and the acceleration to this side is we found out 0.5 ms minus 2. This is acceleration to this side is 2 ms minus 2. Now we need the acceleration magnitude and the direction. So this is A. So magnitude is mod A is 0.5 square plus 2 square square root. So that is going to be 4.25. That is 2.06 ms minus 2. And the direction tan theta equal, so 2 divided by 0.5. So we need actually bearing. Now then we'll work out. This is 0.5 and this is 2. So if I take this is alpha, so bearing is we measure from north. So if I find alpha, it's fine. So this is 0.5. Tan alpha equals 0.5 over 2, or half over 2, which is 1 over 4. Alpha is tan inverse 1 over 4. So this is going to be 14 degrees. 14 degrees. So bearing is 0, 1, 4. So we found out the magnitude of the acceleration and the direction. So if we want, we can find the magnitude of the resultant force R equal 4 square plus 1 square root, that is 20. 4 square 70 square root 17, and we can find the direction of the force. Tan theta is going to be 1 over 4. Sorry, tan theta, this is 4 and this is 1. So this is 4 over 1. Theta equal tan inverse 4 over 1, which is tan inverse 4. So this is alpha, I took as this one. This is theta. So alpha plus theta equal 90. So theta equal 90 minus alpha in other way. 90 minus 0.14. So 14 degrees. So 14 degrees, it's going to be 76 approximately. So this answer has to be 76 approximately. Oh, this is theta. So tan theta equal 2 divided by 0.5. 4 divided by 1 equal 2 divided by 0.5. 2 divided by half, which is 4. Tan theta equal 4. So the direction of the acceleration you can take, it's the same as the direction of force. If you feel this is confusing because of this bearing thing, so simply what I said was, when you look at tan theta, in terms of force, 4 divided by 1. So theta equal tan inverse 4. Again, tan theta you can write in terms of what? Acceleration component. So 2 divided by 0.4. So this is 2 divided by half, which is 4. Still the same, theta equal tan inverse 4. Basically, if you need the acceleration direction, you can find from the resultant force direction. This is the resultant force. Or if you need resultant force direction, you can take the acceleration direction. Because why? The particle is moving towards the resultant force. Now question 2. Force is given if 4i plus 3j. Now acceleration also given 20i plus 15j. Then we want to find the mass. So F equal ma, F equal 4i plus 3j times m is we don't know, and a is 20i plus 15j. So this is a vector equation. Have you learned about vector division? Have you learned anything about vector division? So m equal 4i plus 3j plus 20i plus divided by 15j. So we have to solve this as a vector equation. So this is 4i plus 3j equal, expand this one, 20mi plus 15mj. So comparing vector I components, so this is 4. This side has to be equal to this one, then this one separately equal to each. So 4 has to be equal to 20m. So m equal 1 over 5. So same as, you can check this one. The answer is right. Comparing j vector, comparing coefficient of I. Coefficient of I comparing coefficient of j. So this is going to be 3 equal 15m, m equal 1 over 3 over 15, 1 over 5. Question 3. M is given 3 kg. So F is the issue. A is given 7i minus 3j. M is 2. Now this particle is moving 7i and 3j to this direction, 3j. So this is 7i. It means when I can see there the triangle. Oh, this is going to be 3j, 7i. So it is moving to this direction. This is the resultant force direction basically. F equal ma. So F equal 3 times 7i minus 3j. So this is going to be 21i minus 9j. So now this is Newton. So the force for this Newton in terms of Newton, this is minus 9j, and this is going to be 21i Newton in terms of Newton. So find the magnitude of the bearing. So this is part A, part B, and the bearing. So we can find the magnitude of F is 21 square plus minus 9 square equal 522 square root, that is 22.9 Newton, and tan theta. So if I take this is theta, so tan theta equal this distance is 3 and this distance is this distance in terms of Newton, that is 9 Newton, because this is 9j, so this is also 9j. So 9 divided by 21, so you can write the same thing in terms of acceleration if you want, that is this is not, this is 3 and this is 7, 3 over 7 is straight, both same, both has to be same. So theta equal tan inverse 3 over 7, theta equal tan inverse 3 over 7. But it is better to stay with this one, because work like this 3 over 7, then you have to explain why you select this acceleration, and you want to explain that the acceleration and the direction of acceleration and direction of resultant force is same. So because of that, just stay with this. So now theta equal 23.19. So we found out this is 23.19. We need the bearing. So we want to tell that the y-axis bearing is 90 plus 21.19. That is approximately 113. Question number 4. Question number 4. So we need to find F1 given, F2 given, acceleration we need to find. F equal ma. So there are two forces, 2i plus 7j plus minus 3i plus j equal m is 0.25. I write 1 over 4 times a. So this is 2 minus 3 minus I plus aj equal 1 over 4 times a. So this is multiplied by 4 times minus I plus aj is a. So minus 432j equal a. So this is the particle, and it has 2 Newton here and 7 Newton here from F1, and then from here 3 Newton to this direction and other 1 Newton to this direction. So then we turn this one into a single one by adding, when you add 3 plus 2, so this direction minus 1, so this to this direction 1 Newton remaining, and then up it is going to be 7 plus 1, 8 Newton. So this is 1 Newton and this is 8 Newton. Now F equal ma we put, so this is minus I plus aj equal m is 1 over 4 times a. So a equal 4 times a minus 4i plus 32j. When you simplify this force, So this is equal to this system. If you want, you can write one more step here. F equal ma, then f1 plus f2 equal m times a. So part B, f equal ma, so this is given f1 plus f2 equal m times m is given 6 kg, 6 times 8. So f1 is 3i minus 4j plus 2i plus 3j equals 6a. So this is 5a minus j equals 6a. So a equal 1 over 6, 5i minus j. So this is a vector. We can multiply by a vector with a scale. So 5 over 6i minus 1 over 6j. So f equal m is f1 plus f equal ma, f1 plus f2 times m times a, that is minus 40i minus 2j plus 25i plus 10j equal m is in this one 15, so 15 times a. So this is going to be minus 15i minus 5j minus 10j equal 15a. So a equal minus 1 over 15 minus 15i minus 10j. So 15 over 15i minus 10 over 15j. So this is minus I minus 2 over 3j. ms minus 2. Part D, this is given f equal ma, so f1 plus f2 equal m times 3 over 2 times a. F1 is minus, sorry, if we have a problem, you can write 0i plus 4j or just 4j. So 4j plus so since this is a negative one, I'll write in bracket to avoid the mistakes. So 4j minus 2i plus 5j equal 3 over 2. So this is going to be minus 2i plus 9j equal 3 over 2a. So a equal 2 over 3, 2 up 3 down, 2i plus 9j. So this is going to be minus 4 over 3i plus 6j. Question number 5. F equal ma. So m is given 8 kg. So f1 plus f2 plus f3 equal 8 times a. We can find the acceleration. That is 3 minus 1 plus 2 minus 5 plus minus 1, 0 equal 8a. So 3 plus 2 minus 1 minus 1 minus 5, 0 equal 8a. So this is going to be 4 and this is going to be minus 6 equal 8a. Then a equal 1 over 8 times 4 minus 6, that is 4 over half, and minus 6 over 2, that is 2 minus 3a. Sorry, this is 8 not 2. So this is 4 over 8 and 6 over 8. 4 over 8 is half. 6 over 8 is 3 over 4. So this is 0.5 and minus 0.75. So A equal 0.5I minus 0.75 J M is minus 2. So mod A, the magnitude of A is plus minus 0.75 square, that is square root 0.8125 square root. Tan theta equal 0.5 divided by, so this is the particle. So this is 0.5, this is 0.75 downward. So this is 75. So tan theta equal 0.75 divided by 0.5, that is 3 over 2. Theta equal tan inverse 3 over 2. So that is going to be 56. And if you need the bearing, then bearing is 90 plus 56, that is 146. This value is 0.091913, and the bearing is this. Now we need to find part B. The time taken to travel 20 meter. So A equals 0.901 ms minus 2, and U equals 0 at rest is given, and we need to find T. So S equal ut plus half at square. So S equal 20 meter, 0 times T plus half times 0.901 times T square. T square equal 20 times 2 divided by 0.901. So T is square root 20 times, that is 40 over 0.901. So this is, you will get 6.66 second approximately. Question number 6. Two forces. I will take one force is F1. 2I plus 3J. Another one is Pi plus Qj acted upon the particle. The resultant force R equal F1 plus F2. So R equal 2 plus Pi plus 3 plus Qj. So I add straight. I said okay. 2I plus 3J plus Pi plus Qj. So I write in this form. Now it is given that, so this is R, direction of R. So this R is parallel to vector minus I plus 4J, minus I plus 4J. Now you can remember that if this is a vector A, then you can write this is lambda times A if those two are parallel. Another one parallel to this one, you can write mu times A. Size is difference only. We can write parallel vectors like this. If we know this is A, this is lambda times A, this is mu times, this is a portion of A's. So likewise now, this is minus I plus 4J. I can write, since this R vector is parallel, So since we know this one, we can write R, or this is lambda times minus I plus 4j. This R mean, vector R mean minus I plus 4j. Hence 2 plus P times I plus 3 plus Qj equal lambda times minus I plus 4j, as uh, R is parallel to minus I 4j. Now this is a vector equation you have to solve. So this is 2 plus P E times I plus 3 plus Q times J equal minus lambda I plus 4 lambda J when you get the coefficient of I component. So this is 2 plus P equal minus lambda. J you can write 3 plus Q equal 4. This is 4 lambda. 4 lambda. So from here you can write lambda equal 3 plus Q divided by 4. We want to show that 4P plus uh, Q plus 11 equals 0. In here there is no lambda or any other symbol. So I need to, so there are two equations. This is one and this is, I will take this one is 2. So I have to, from 1 and 2 I want to delete lambda or get rid. So I can substitute, or if I add 1 plus 2 I can see this is cancel out. Minus lambda plus lambda is 0. So 2 plus P plus 3 plus Q divided by 4 equal 0, because plus lambda minus lambda plus lambda equals 0. So when you, this is fine, 4 times 2 8 plus 4P plus 3 plus Q over 4 equals 0. So this is 11 plus 4P plus Q equals 0. So you can write in this form 4P plus Q plus 11 equals 0. Question number 7. A particle M is 4 kg and F is given 6I plus R is 6I plus Bj resultant force Bj, and bearing 45. So bearing 45 means, so it is, this is the angle. It means this result forces, this is definitely in the first quadrant. So two forces should be here to go to this direction. So this is 6I and Bj. B, if it is positive in here, negative in here, then if it negative in this direction, it will move. So then this is 6I and this is Bj. So because this is Bj. So this is also 45, because this is 45, then 90. This is also 45. So tan 45 equal B over 6. So B equals 6 tan 45. Tan 45 equal 1. So this is 6 Newton. It is true that because if you enter similar forces, let's say this is X, or let's say N, and this is also has to be N. That is, then it is going to 45, 45. 3, 3 go 45. Or 4, 4 go 45. 2.455, 2.5. If you apply equal forces to this direction, it is go 45 degrees. Now R is 6I plus 6g. So mod r is 6 square plus 6 square. So 2 times 6 square 36, 72. So this is going to be actually 2 times 36, 6 square root 2. Now part C, we have to work out the acceleration. So now we know that r value is 6 square root 2, m equal 4, and f equal ma. 6 square root 2 equal 4 times a equals 6 over 4 square root 2, so 3 over 2 square root 2, ms minus 2. Part D, we want to calculate the distance travel within 5 seconds starting at rest, and a we have now 3 over 2 square root 2 is equal ut half at square is equal 0 times 5 half 3 2 square root 2 times 5 square. So this is equal 3 square root 2 over 4 times 25, 75 over 4 square root 2 meter. Question number 8. Three forces in equilibrium. So F1 plus F2 and F3, when you add, this is equal to 0. So then minus 3 F1 is minus 3 7, and F2 is 1 and minus 1, and F3 is P and Q equals 0. So minus 3 plus 1 plus P, so this is 0 0 uh, times 7 minus 1 plus Q equals 0 0. So this is going to be minus 2 plus P, and this is 6 plus Q equals 0 0, and 2 plus P equals 0, P equal 2, and 6 plus Q equals 0, Q equal minus 6. And the next part is given that the first 10 seconds motion is travel to L, so we want to find the uh, m of this particle, weight of the particle. So we have to use F equal ma, but we know F now. We found out um, after that for next question, the F2 is removed. Then you have the resultant force F1 plus F3. So F1 is minus 3 7, and F3 is P and QP equal to 12. This is minus 6. So minus 3 plus 2, 7 minus 6. So this is going to be minus 1, 1. So magnitude of R is minus 1 square plus 1 square, square root, that is square root 2. Now it is given that find first 10 second. So SC T equal 10, S equal 12 meter, and U at start is at rest. So we need to find A, to then S equal UT plus half AT square. S is 10, 12, and this is going to be 0 times 10 plus half times A times 10 square. So 12 equal 50 A. A equal 12 divided by 50, 6 divided by 25. Then we'll consider F equal ma to that particle without F3 for this system. So F is square root 2 now, and M we need to find, and A is 6 over 25. So M equal 25 over 6 times square root 2 kg. So we want to find M. We have to use F equal ma. We know F, but we don't know A. So the details is given here to find A, and we apply and we get M. Question number 9. Mass M has given three forces, and we need to find the M. So R is given 5, 6 plus 2 minus 2 plus minus 1 minus 4, that is 5 plus 2, 5 plus 2 minus 1, 6 minus 2 minus 4, so 7, 6, so this is 0, so this is 6i plus 0j. So F equal ma when you put, so this is going to be 6i plus 0j. Actually, we can see that this is 6i plus 0j. This is just 6i. It means particle we have a 6 Newton force. So simply we can put F equal ma without the vectors. F value is 6 and M we need to find. A is given as 7, so M equal 6 over 7 kg. So F equal 6, S equal 7, M is minus 2, and we need A, so this is how it is. 0.86 kg approximately. Question number 10. Two forces is given, so we need to show that 2p plus q equal, so first of all find r, so that is 2p plus 5 pq, so this is 2 plus p, 5 plus q. So r is parallel to vector is given I minus 2j vector, so this is parallel to r. So this r is, you can express as lambda times 1 minus 2j, I minus 2j. So r equal lambda times I minus 2j, this is vector r. Then that is 2 plus p I plus 5 plus qj equal lambda times I minus 2j. So this is lambda I minus 2 lambda j equal 2 plus I plus 5 plus q j. So when you consider I, you will get 2 plus p equal lambda. When you consider j, you can get 5 plus q equal minus 2 lambda. We'll take this is 1, this is 2. Then we'll substitute 1 into 2. So substitute 1 to 2. So 2 is 5 plus q equal minus 2 times lambda. Lambda we know 2 plus p. So 5 plus q minus 4. 2 times 2 minus 4 plus 2p. Sorry, this is going to be minus times plus minus. So then everything to this time, 2p plus q plus 5 plus 4 equals 0. 2p plus q plus 9 equal 0. So next part, given p equal 1. When p equal 1, q is 9 minus 2p. So minus 9 minus 2p. So minus 9 minus 2 times 1, that is going to be minus 11. So this one force is now from here, r is 2 plus p, 5 plus q equal 2 plus p is 1 and 5 minus 11, that is 3 and minus 6. So more magnitude of r is 3 square plus minus 6 square root, that is 39 plus 36 square root. So that is square root 45. Now r is square root 45 and a is given 15 square root 5, m is minus 2. Now we need to find m. So f equal ma. So m equal f divided by a. F equal square root r. So if value is r, square root 45 divided by 15 square root 5. So this is going to be 9 times square root 5 over square root 15 times. Cancel out, this is 3 over 15, that is 1 over 5. So this is 0.2 kg.